David,
Yeah,
can you see and hear me?
yeah, I can do it. Yeah.
Okay, let's start. So, today we're going to go over inequality and the number line. So, the concept of inequality and the number line. But before we do that, let us do a quick review of what we learned last time. So, last time we went over place value and expanded notation. So let's say we had an example of a very large number, like this. What place value is this number? 8.
100 billion.
Okay, so
Well, actually, no, 100 million. 100
good.
million.
Yeah, million. Because we're in these three right here. These three are in the million section. What about this one?
100 thousands.
Mm-hmm. What about this one?
Hundreds.
What about this one?
876 million.
Well, this 7 only. What place
Uh,
value is this 7?
uh, 10 million.
Yep. What about this one?
10 thousands.
And what about this one?
Tens.
Mm-hmm. And this?
Millions.
What are the 3?
Oh, uh, 100. Thousands.
Mm-hmm. And this?
Ones.
And what about this 9?
That's billion.
Billion, right? Billion?
Yeah.
Yeah, it's in the billions place. And how would we say this whole number in words? How do we say it?
9,876,543,000
Yeah. So 9,876,543,210. And so here's the same number. I'm just going to write it one more time. How would we write this number in expanded notation? So I'm going to start with the 9. Okay. And what do I multiply that by?
1 billion.
Yeah. And then what do I do here? Do I add or subtract or?
Add
Yeah. I'm going to add the next digit, which is 8. And I'm going to multiply that by what?
800 million. I mean, 100 million.
Yeah. 100 million. And then the next digit is what? 6. So 6 times. Sorry.
Uh,
7. It's 7. 7 times what?
one, 1 Or
What place?
what? 10, 10 million,
Mm-hmm. So that's 10 million. It's got what, 7 zeros plus. What about this 6? What do I
1
multiply?
million,
Yeah. And what about the 5?
100,000,
And the 4?
10,000,
And the 3?
1,000,
And the 2?
100,
And the 1?
tens.
And do I have to write the 0?
No,
No, because so if I did that, let's say I wanted to do 0 times 1 because it's in the ones place. Well, what 0 times anything?
0.
0. Anything times 0 is 0, so this wouldn't even matter. Okay, so you don't need to do expanded notation for that 0 at the end. Um, what happens if I add? What happens if I do this multiplication and add every one of these? What do I get?
9 billion.
And 9 billion.
Oh yeah, 9,876,543,210.
Yeah, that's what we get. Okay, when we actually do the multiplication and addition for expanded notation, we get the number. By the way, I don't think I mentioned this last time. This, what we did here just now, is called expanded notation. This regular number, just a number itself, is called standard form of a number. Okay?
Good.
All right. Let's go over what we need to go over today, which is inequality and the number line. So far, the numbers that we've been dealing with have been what are called whole numbers. Whole numbers are numbers that start with 0 and go increase by 1 each time. So 0, 1, 2, 3, 4, 5, 6, so on until it goes to all the way to infinity. In other words, this, you know what this symbol means? Infinity?
Infinity.
Yeah,
Yeah.
it means it goes forever. It doesn't stop. Okay? It's not exactly a number, it's more of an idea or a concept. But that's what whole numbers are. Starts at 0. Okay? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. The other concept you need to know is the idea of the number line. Okay? The number line. And that's a visual representation. In other words, it's a picture, okay, of different number systems. So if I wanted to represent whole numbers on the number line, what would I do? I would, I would draw this arrow, this double-sided arrow. Actually, sorry, I wouldn't draw a double-sided arrow because it starts at 1, okay, meaning it ends at 0 on the left side. So I would do this. An arrow pointing all the way to the right. And it starts here at 0. And I would do increments of 1. Just keep adding 1 to get the next one. So I have 1. If I add 1 to that, I get 2. I get 3. I get 4. I get 5. I get 6. And I get 7. And this arrow tells me that these numbers go on forever to infinity. Okay?
Good.
Okay. So that's what the number line is for whole numbers. Later on, we're going to learn about integers, which are negative numbers that go in the opposite direction of the whole numbers. Okay, it goes towards the left, but we're not doing that now. We're just using whole numbers. Therefore, we're starting at 0. Okay. Again, this is just we're just recalling what I just told you. Properties of the number line: numbers increase from left to right, and numbers decrease from right to left. So this is a fact that you need to kind of remember in your head. Just know that when we go right, the numbers are getting larger. They're always getting larger. When we go left towards 0, the numbers get smaller. Okay? And this is very useful, okay, for comparing numbers. Okay? That's one of the uses of a number line, is for comparing numbers with other numbers. So if I'm talking about 1 here, so I have 1 and I have 6. Is 6 larger than 1 or less than 1?
It's larger, actually.
It's larger because it's to the right. So if I pick a number, you do have your pen and paper, right?
Yeah.
Okay. So here's the whole number line. We have 0 here, and we have positive infinity. And I have some numbers here. And let's say this, you have 1, 2. If I choose 1, then any number to the right of it is going to be larger than 1. So 2 is larger than 1, 3 is larger than 1, 4, 5, 6, 7, 8, so on. The only number that's actually less than 1 would be this number, only 0. That's it. Okay? If I chose instead another number, let's say I chose the number 5, and this is 0, what are some of the largest larger than 5? What comes after 5? 6?
7, 8.
Yeah. And so on,
9.
right? Yeah. And what are some numbers that are smaller than 5?
4, 3, 2, and 1.
Yeah, good.
And 0.
Yep. Okay. So let's move on to the idea of comparing numbers then. So in math, when we compare numbers, we use symbols. Okay, symbols. And let's go over the symbols. So the first one you're going to learn about is the equal sign, meaning whatever you're comparing, they're equal. In other words, they're the same thing. So I have 9 question mark 9. What should I put? Is 9 equal to 9?
Yeah.
Yeah. So this is true. 9 does equal 9. So we can put an equal sign in between them. What about this one? Here we're comparing on the left, we have 9. And then on the right, we have 9 times 2 divided by 2. And when we have expressions in parentheses, we always do them first. So let's try that. So here on the left, we just have 9, but on the right side, we have 9 times 2, which is what?
18.
18. And let's divide it by 2. What's 18 divided by 2?
9.
9. So on the right side, we have 9. And on the left side, we have 9. Are these equal?
Yeah, actually.
Yeah, they're equal. When you look at these two things, it says 9 question mark. And then on the right side, we have 9 times 2 divided by 2. At first, they don't look equal. But when you work it out, right, 9 times 2 is 18. 18 divided by 2 is 9. We find out that they're indeed equal. Okay, so the other symbols you need to know is these are called strict inequality signs. Strict inequality, okay? That is the greater than symbol, and this is the less than symbol. And how we can remember this easily, because I know sometimes we forget, is if you look at the face of a clock. Okay? Not the digital clock on your watch or your phone or the computer, but this is a regular clock, the circular clock on the wall, we have 12 o'clock right here. That's where we start. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 o'clock, 10 o'clock, 11 o'clock, and we're back at 12 o'clock, okay? Notice how to the right, if I have a sign that opens up to the right, notice how these numbers, 1, 2, 3, 4, 5, 6, are less than the numbers on the left. So one way to remember is if it looks like that, it's opening up to the smaller numbers, 1, 2, 3, 4, 5. So it's less than. That's how you know it's less than. If it opens up to the left, notice how all the numbers are larger. 7, 8, 9, 10, 11, 12. So that's how you can remember that when an inequality sign opens up to the left, it means greater than. Okay?
Okay.
Okay. All right, so let's compare some numbers. Let's try this example. 3 question mark 10. Is 3 less than or greater than 10?
It's less than.
Less than. And the sign is this, less than. It's a, think of it as, you know what Pac-Man is?
Yeah.
Pac-Man game, you've seen it? Think of it as the Pac-Man mouth. And it's opening up to the right side because what's on the left, 3, is less than what's on the right. Okay. And why don't you try this one? 10 question mark 3. Less than or greater than?
Wait, 10 is greater than 3?
Yeah, 10 is greater than 3. 10 is larger. Okay. On the number line, 3, we have 0 here. 3 would be right here, and 10 would be somewhere over here. So 10 is larger than 3, is what this is saying. Okay. And the key is inequality symbols always open up to the larger number. So here we're saying, in this example, David, we're saying 3 is less than 10, but the sign itself is always opening up, like the Pac-Man mouth. It's opening up to the larger number, right? And here we have 10. 10 is greater than 3, so it again opens up to the larger number. Okay?
Okay.
All right. Now we go to the non-strict inequality. So these were the strict inequality signs, greater than and less than. These are non-strict inequalities right here. And this means greater than or equal to. Okay, in other words, it can be either larger or it can be equal to the number that's being compared. So what's on the left is going to be either greater or equal to what's on the right. And this one is less than or equal to, meaning what's on the left can be either less than or equal to what's on the right. Okay?
Okay.
All right, so let's try this one. We have 9 less than, parentheses 9 times 2, divided by 2. What do you think this is? Is 9 less than or equal to 9 times 2 divided by 2? Is it true or false? Let me know when you're done.
It's true, actually.
Okay, so let's actually work through this. So 9 times 2 is what?
18.
18. What is 18 divided by 2?
9.
9. So what this is saying 9 is less than or equal to 9. And yeah, it's true because 9 is equal to 9. Okay, 9, so what's on the left can be either less than or, this is the important part, or equal to what's on the right. Therefore, this is true. Okay. Let's try another example, true or false, and let me know when you're done.
Right.
What did you get?
False.
Okay, so the first one was true, and this one you're saying this is false. All right, let's see what's going on here. On the left, we have 9, and we have greater than or equal to 9 times 2 divided by 2. We did that above. So this is saying, so this is 9. Okay, so what this is saying is 9 greater than or equal to 9. And yeah, again, it's actually, it's true, right? Look at
Yeah,
what's,
but they're yeah.
huh?
Well, 9 isn't greater than 9 because it's equal to each other.
Right. But remember how it's saying greater than or equal to. So if they're equal, it's still true. Do you understand? Remember this one, it was the same thing. 9 is less than or equal to 9. So 9 is not less than equal to 9, right?
Yeah.
But is it equal to 9? Is 9 equal to 9?
Yeah.
Yeah. And so if this is true, it's equal to or equal to, so it's true. Same thing on this one. Is 9 greater than 9?
No.
No, but is 9 equal to 9?
Yeah.
Yeah. Therefore, this is true. Okay? All right, let's move on. The other sign. So far we've been through greater than, less than, greater than or equal to, and less than or equal to. The other sign is this one. It's an equal sign with a diagonal line going straight through it. And what does this mean? What does it say right
Not
here?
equal to.
Yeah, not equal to, meaning they're not the same. All right, so let's try this example. True or false? We have 5 not equal to 2 times 6. What do you think?
True.
Okay, so we have 5 on the left, and it says not equal. 2 times 6 is what?
But 12.
Yeah. And 5 is not equal to 12. Therefore, this is true. The true statement. Good. All right. So that's it for that. And let's see. Let's do homework. So your homework for today, pre-algebra assignments. Same instructions. So which we've done place value, we've done expanded form. Now you're going to do this one, pre-algebra inequality in the number line. You're going to do it on a piece of paper with either a pen or pencil and DM me a picture of it. Okay?
All right.
Okay. That's it. Good job.
All right.
Bye-bye.
Bye.